Chapter 03, Steady-State Theory. What is the steady-state theory? In 1948, three British scientists named Fred Hoyle, Thomas Cole, and Hermann Bondi came up with a new idea about how the universe works. They called it the steady-state theory. At that time, the Big Bang theory was becoming popular, but these three scientists opposed that idea. They wanted to create a different explanation. Fred Hoyle was especially against the Big Bang theory. Instead, Hoyle and his friends wanted to explain the universe in a way that didn't need a beginning or an end. The main ideas behind the theory: the steady-state theory is based on something called the perfect cosmological principle. This is a fancy way of saying that the universe looks the same everywhere and at every time. Think of it like this. If you could travel to any place in the universe, or to any time in the past or future, everything would look pretty much the same. This was very different from the Big Bang theory, which says the universe started very hot and dense and has been cooling down and changing ever since. The steady-state theory says the universe has always looked the way it does now, and it always will. The theory has three main features. The universe is always expanding. Just like other scientists had discovered, the steady-state theory agreed that the universe is getting bigger. Galaxies are moving away from each other, and space itself is stretching. But unlike other theories, this expansion doesn't change how the universe looks overall. New matter is always being created. Here's where the theory gets interesting. If the universe is expanding but always looks the same, then new matter must be appearing to fill in the empty spaces. Think of it like a balloon that's being inflated, but someone keeps adding more dots to the balloon, so the number of dots per square inch stays the same. In the universe, new atoms and particles would slowly appear in empty space, eventually forming new stars and galaxies. No beginning, no end, because new matter is always being created. The universe never runs out of stuff. It has always existed and will always exist. There was no moment when everything started, and there will never be a moment when everything ends. Why did people like this idea? Many scientists and philosophers found the steady-state theory attractive for several reasons. It avoided difficult questions. The Big Bang theory raised uncomfortable questions like what caused the universe to begin and what existed before the Big Bang. The steady-state theory didn't have these problems because it said the universe never had a beginning. It was simple and elegant. The idea that the universe has always been the same seemed cleaner and more straightforward than the idea that it started from a tiny, incredibly hot point and has been changing ever since. It fit some observations. Scientists had already discovered that the universe is expanding, and the steady-state theory could explain this expansion while keeping everything else constant. How the theory explained what we see. The steady-state theory had explanations for the things astronomers could observe. Why galaxies are moving away? The theory said that space itself is stretching, causing galaxies to move apart. But as they move away, new matter appears in the gaps to form new galaxies, so the overall picture stays the same. Why the universe looks uniform according to the theory. If you looked at the universe from far away, it would look the same at any point in time. Galaxies of all different ages would exist at the same time. So looking into the distant past would show you a universe very similar to what we see today. The creation of new matter. The theory suggested that new matter appears very slowly, so slowly that we could never detect it directly. This new matter would gradually clump together to form new stars and galaxies, replacing the ones that moved too far away to see. Problems with the theory. At first, many scientists liked the steady-state theory because it seemed to explain things well, but as astronomers made new discoveries, they found evidence that didn't fit with the theory. Quasars and distant objects in the 1950s and 1960s. Astronomers discovered extremely bright objects called quasars. These objects were only found very far away, which means they only existed in the early universe. If the steady-state theory were correct, we should see quasars nearby too, because the universe should look the same everywhere and at every time. But we don't see any quasars close to us, which suggested the universe has changed over time. The cosmic microwave background. Scientists discovered something called the cosmic microwave background radiation. This is a faint glow of microwave energy that fills the entire universe. The Big Bang theory predicted this radiation should exist as leftover heat from when the universe was very hot and dense. The steady-state theory couldn't explain where this radiation came from, because it said the universe was never hot and dense in the first place. Galaxy evolution astronomers also noticed that galaxies far away, which means we're seeing them as they were long ago, look different from nearby galaxies. This showed that galaxies change over time, which contradicted the steady-state idea that everything should always look the same. The end of the theory. By the 1970s, most scientists had given up on the steady-state theory. The evidence against it was just too strong. The discovery of the cosmic microwave background radiation was especially damaging because it provided clear evidence that the universe was once much hotter and denser than it is today. The Big Bang theory, on the other hand, successfully predicted the cosmic microwave background and explained all the other observations that the steady-state theory couldn't handle. Why the theory was important? Even though the steady-state theory turned out to be wrong, it was still very important in the history of science. It encouraged scientists to think carefully about the universe and test their ideas thoroughly. The debates between supporters of the steady-state theory and the Big Bang theory led to better observations and experiments, which ultimately helped us understand the universe better. The theory also showed that it's okay for scientists to propose bold, new ideas, even if they turn out to be incorrect. Science progresses by testing different explanations and keeping the ones that work best. Conclusion: the steady-state theory was a creative attempt to explain the universe without requiring a beginning or end. It suggested that the universe has always existed in roughly the same state, with new matter continuously being created to maintain constant density as space expands. While this elegant idea avoided some philosophical problems and was popular for a time, new astronomical discoveries showed that the universe does change over time and likely began with a Big Bang about 13.8 billion years ago. Today, we know the steady-state theory was incorrect, but it remains an important part of the history of cosmology. Next video. Chapter 04. Multiverse Theory Explained. Thank you for watching. Hope you got a clear idea about the steady-state theory. If so, please like, subscribe to watch more videos, and share with like minds.